Hello, Dr. Slatford here, and welcome to this presentation on doing mole calculations when we've got two solutions. As per normal, I do expect you to come with some previous knowledge. The first one is that you should know how to calculate the number of moles from a certain volume or a given volume of a known concentration of a solution. And you should also be comfortable rearranging formulae which involve mole calculations, particularly those involving the concentration, volume and moles triangle. Okay. Now, many reactions that we do in chemistry involve two solutions. Just to highlight this, I'm just going to ask you, in your practical experience, how many times have you been asked to do something like this method? So if you're using a measuring cylinder, place 5 cubic centimeters of reactant A in a test tube, and now you want to add a few drops of reactant B, and you're going to look and record some observations. And then you get something like this happen, where, oh, look at that, it's a red precipitate, woohoo, brilliant. Okay, fine. But what you probably didn't realize is that actually these solutions have been prepared probably either by your teacher or more likely the technicians that are working in your school to a specific concentration so that it actually works and it aids your observations. So you actually find the correct things. So we're going to do some calculations now where we're going to specifically look at concentrations. Okay, so in this first worked example, I'm going to ask this question. In a neutralization reaction between 1 molar HCl and 1 molar sodium hydroxide, and you should remember that 1 molar is equal to 1 mole per decimeter cubed, what volume of sodium hydroxide am I going to need to react with 25 cubic centimeters of 1 molar HCl? Okay, so the two things that I'm interested in, I'm going to underline. Okay, and I'm going to remember here that 1 molar is 1 mole per dm cubed. I need to remember that the moles of HCl that I'm going to be using is the concentration in moles per decimeter cubed multiplied by the volume in decimeters cubed. Okay, so the concentration I've been given is 1. I need to convert my 25 cubic centimeters to decimeters cubed, so I divide by 1,000. So 1 times 25 over 1,000 is equal to 0.025 moles. But my balanced symbol equation tells me that I've got a 1-to-1 reaction, and this tells me that the number of moles I use of HCl is equal to the number of moles of sodium hydroxide that I'm going to use. So the number of moles of sodium hydroxide I use is therefore also equal to 0.025. And I can now convert that back to volume, because now volume of sodium hydroxide used is equal to moles divided by the concentration. And all I've done is rearranged my equation here. Once I put the numbers in here, and that becomes 0.025 divided by 1, which equals 0.025 decimeters cubed. To convert that back, I times it by 1,000, and I get 25 cubic centimeters. The second worked example I'm going to work through is this. So a neutralization reaction is performed between 1.5 molar HCl and 0.4 molar sodium carbonate. What volume of sodium carbonates will I need to use to react with 25 cubic centimeters of 1.5 molar HCl? And I'm going to do exactly the same here as I did in my previous example. I'm interested in these two reagents. The moles of HCl used is the concentration times by the volume. And here again, I use 25 cubic centimeters, which is 25 over 1,000 dm cubed. My concentration was given as 1.5. So that comes out as 0.0375 moles. But the number of moles of sodium carbonate is half that compared to hydrochloric acid. So the number of moles I use in my reaction is half of 0.0375, which equals 0.01875 moles. And I now need to convert that back to a volume, which is again rearranging this equation here. So moles divided by concentration, so that becomes 0.01875 divided by 0.4, which is 0.047 decimeters cubed. Converting that by multiplying by 1,000 to cubic centimeters, I would have needed 46.9 cubic centimeters of 0.4 molar sodium carbonate to react with 1.5 molar hydrochloric acid. Thank you very much for watching, and have a pleasant time doing even more mole calculations involving solutions and concentrations. And the next stage from this is going to be titrations. Bye bye for now.